Hello and welcome to another presentation, this time on integration. I'm going to be going through a couple of problems. There's not much integration at AS level. It's mainly finding areas under curves and also solving differential equations. So I'm going to go through one example of each. Here's an example where we've got to find the area bounded by a curve, namely y equals 2 minus x 5 plus x, so quadratic, the x-axis and the y-axis. Now, as I always say to students, if they just give you the wordy part of the problem, do draw a picture of what's going on. So we've got a quadratic. Notice it's upside down as well. I call them upside down anyway, maybe that's the wrong way of putting it, but we're going to have 2 on that axis and minus 5 here. And so what area is it asking us to find here? Well, it must be this area, because this area is bounded by the x-axis, the y-axis and the curve. You could argue that possibly the question is ambiguous because that area there is also bounded by the curve, the x-axis and the y-axis. I would always take the area on the right to be the one which they're asking for. They should really give you a picture, because otherwise the question is a little bit ambiguous. I agree with you. Let's just find that area on the right hand side. Okay, so we're going to need to start by integrating. We're going to be finding the area between 2 and 0 and then we're going to need to multiply this out. We're going to get 10 minus 5x plus 2x, which is minus 3x, and then minus x squared, and we're going to integrate that with respect to x. That comes to 10x minus 3x squared over 2 minus x cubed over 3. Between 2 and 0. Plug those values in and you're going to get 20 minus 4 times 3 is 12 divided by 2 is 6, and then you're going to get minus 8 over 3 as well. And then in your second set of brackets, if you like, when you plug in 0, you're just going to get 0 for every single term. I still get students to write that down, because certainly in A2, when you're plugging in 0, it doesn't necessarily mean you get out 0, because let's say you're plugging it into e to the x, well, that would be 1. And so you've got to be careful of assuming that it is, what you think it is. Okay, let's take it away now. We've got 14 minus 2 and 2/3, so that's going to be 11 and 1/3. We've found that area. But yeah, that was a little bit ambiguous, that question. I do agree. I suddenly realised, there's actually 2 different areas there which are bounded by the curve, the x-axis and the y-axis. Maybe if I said the positive x-axis, that would fix the problem. Okay, let's have a look at solving a differential equation next. Okay, here we're going to solve dy by dx equals 3 over x squared plus 2 root x, given that the curve goes through, and let me write this up here, given that the curve goes through, and I think the curve's going to go through 1, 5, isn't it? X is 1, y is 5. Good. Okay, we didn't actually have to pick 1, 5 there. I could have picked any value. Obviously, it doesn't have to satisfy the differential equation. In fact, I might have misled you there, because I think I was thinking rather foolishly. So let's actually change that to, because this can be any value you like, because there's an infinite number of solutions to any differential equation. As soon as you give a coordinate it goes through, then you've only got one particular solution to that differential equation. So let me just put that in as a 10, just for fun. The 1's quite handy though, because there'll be square roots in it, so it'll make it easier on my brain after I integrate. Okay, so let's integrate this, because obviously if you're given dy by dx and you want to find y, you need to undo the differentiation, and you do that by integrating. Now, before we do that, we really want to write this in a slightly friendlier format: 3x to the minus 2 plus 2x to the half. And often at AS level they will need to do that. Now we're in a good position. Increase the power by 1 and divide by the new power, and you're going to get minus 3x to the minus 1. Increase the power by 1, you get x to the 3 over 2, and then we're going to need to divide by 3 over 2, but that's the same as multiplying by 2/3, and therefore we get 4x to the 3 over 2 over 3. And then what everybody forgets, me included, is to put the plus c on the end. Once you've got the plus c on the end, we can plug in the coordinate, and just like in y equals mx plus c, when you sometimes might find yourself doing this, you plug it in and find the value of c, and that will give you the particular solution to this differential equation. So let's do that. That's just going to give us minus 3 plus 4/3 plus c, and therefore we're going to get 13. I'm just going to do this slightly slowly so I don't make a mistake with my arithmetic, which does happen sadly. And therefore we can see now that c equals 11 2/3, very close to the last answer. Okay, and that completes the problem. I always get my students to write the solution out. The final solution is y equals minus 3 over x plus 4/3 x to the 3 over 2 plus 11 2/3, or if you prefer a slightly nicer way of putting it, 35 over 3. And you are finished. I hope that makes sense. It's not too tricky actually, the integration at AS level. It gets very difficult, the integration at A2 level, and yeah, I hope to see you doing that module later on in the course, perhaps you know, the calculus at A2. It offers much more kind of difficult questions, really, much more interesting questions, and you know, the difficult questions are the fun ones. Okay, I will yeah, wish you the best of luck with the course. Keep up the hard work, and well done.